let's do some question on the graph, right? Let's do some question on the graph. So this question, a given graph shows variation of velocity with displacement. This is the variation of velocity with displacement. Which one of the following graph correctly represent variation of acceleration with displacement? Which of the following graph represent variation of acceleration with the displacement? See, acceleration is written as dv by dt, and this dv by dt can be written as dv by dx into dx by dt. Getting a point? dv by dx into dx by dt, or this can be written as v dv by dx. You can write this as v dv by dx. And the equation of v versus x from this graph, see, I told you that if you have a straight line x and y with a over here and b over here, the equation is given by x by a plus y by b equal to 1. So I'll use that slope intercept form over here. So x upon x naught upon v naught equals to 1. Getting a point? Okay. So this is v is v naught x by x naught, or let's put it like this only. V is v naught 1 minus x naught. Alright, and this dv by dx is what? So dv by dx is minus u naught by x naught. So acceleration is v into dv by dx. So v is v naught into this, or this can be written as a upon minus plus equals to 1. And see, x naught is positive, v naught square has to be positive, so this is negative and this is positive. So it will be on the a side, this will be minus v naught square by x naught. This will be x naught. This is the graph. This is the graph. Acceleration versus x is going to be this graph. Are you getting a point? So this is the correct answer. Let's go to next question. The question is, a particle starts from rest. Its acceleration versus time graph is shown like this. You have to find a maximum speed of particle will be. See, you have the acceleration taking place. It's 11. And acceleration is falling, but it's remaining positive. So acceleration is positive means the velocity will keep on increasing. The only thing which can happen is the rate at which velocity increases is falling, but velocity keeps on increasing. But rate at which velocity increases keeps on falling, and initially you see the velocity was 0. So we have to find velocity at 11th second, right? So change in velocity would be given by this graph from 0 to 11, and this is what? This is area under the graph. So this area will be equal to what? This area will be equal to 1 by 2 into 11 into 10. This is 15.5 meter per second. So this will be your answer. You see from where you are getting this. See, A is dv by dt. So I can write dv equals to a dt, and you integrate it. So this will be delta v a dt from t1 to t2, and this is nothing but area under the curve from t1 to t2, and t1 is 0, right? So this is 55 meter per second. This is 55 meter per second. Okay, let's take this case. A ball is dropped vertically from height d over the ground. We are dropping the ball from height d. This is height d. So ball will come like this. It will hit the ground, and as it comes downward, the velocity keeps on increasing. The velocity keeps on increasing, but increases in downward direction. But it keeps on increasing, and then it hits the ground. Then velocity will change its sign. Velocity will become positive. From here to here, velocity was negative, and then it hits the ground, rebound. So velocity become positive, and it keeps on falling and reaches d by 2. See, I'll tell you. It starts from d by 2. Velocity keeps on increasing, but remains negative. The magnitude of velocity keeps on increasing, but it's negative. Then it hits the ground. It reverses the sign. It becomes positive and keeps on falling. So velocity keeps on increasing like this, and the rate at which velocity increases is constant, of course. G is the acceleration, so this won't be the graph. This is not a linear increase in velocity, so the graph would be like this. Velocity keeps on increasing. Velocity is minus gt, keeps on increasing. Then it hits the ground, and the sign of velocity becomes positive, right? And then keeps on falling, and at d by 2 it falls to 0. So this will be the graph. This will be the graph. All right. It goes like this. It keeps on increasing. Goes to say 2dg, and then it hits the ground and rebound, but it rebounds with less velocity, of course, and then only then it can go till d by 2. If it rebounds with same velocity, then it will go to d again, but it rebounds with less velocity, so it's not root 2 dg, it's less than this value, and then it keeps on rising. So velocity keeps on falling uniformly. It will be some velocity v naught minus gt, like this. This will be v naught. Get your point? Okay, so that's the graph. Let's go to next question. The question is, a car accelerates from rest at a constant rate alpha for some time, after which it deaccelerates with constant beta and comes to rest. To come to the rest, so it accelerates with alpha, reaches some velocity, and then velocity keeps on falling because it is deaccelerating now. So the graph of velocity versus time would be what? First of all, it accelerates with alpha. Velocity increases at constant rate. du by dt is alpha, so it increases linearly. Then it reaches some value, say call it v naught, and then it starts falling, it deaccelerates and goes to 0 again, and the time taken is, during this time, is t. So suppose it accelerates for t1 time, and then from t1 to t it deaccelerates. All right. So maximum velocity would be v naught. Maximum velocity would be v naught. V naught would be the maximum velocity, right? So it accelerates to v naught from 0 to v naught with acceleration alpha. So what's the t1 time? See, you got this v naught, 0 plus alpha t1, right? If t1 is the time taken by the body to reach v naught, then we have this graph. See, vt is what? U plus at. It starts from 0 and acceleration is alpha, and the velocity after t1 time is v naught. Is that t1 is the time taken by the particle to reach this maximum velocity v naught, car, time taken by the car to reach this v naught. It is acceleration. So this t1 will be what? V naught by alpha. And thereafter what happens? It starts from v naught and undergo deacceleration and goes to 0. So suppose t2 is the time taken by the car to reach 0. So that will be v naught minus beta t2 is 0. So this t2 is v naught by beta, and this t1 and this t2 added together is T. Is V naught by alpha is T, or V naught will be T into alpha beta, alpha plus beta. That would be the answer. Total distance traveled will be this, and that is half into T into V naught, the area under the graph. Total distance traveled will be area under the graph. So 1 by 2 into T alpha beta. That will be the distance traveled. That will be the distance traveled. Alright. Clear point? You understand this part? So uniform acceleration. We have used this definition. Use this formula. Initially your Vt was V naught. Final velocity is V naught. Time taken is T1. Initial velocity is 0. So we got this equation. From there we get T1. And then when it deaccelerates, your initial velocity is V naught. Final velocity is 0. And deacceleration is beta. This question. This is acceleration time graph of a particle moving in a straight line as shown in figure. Velocity at t equals 0. At this point velocity is 2 meter per second, and we have to find velocity at the end of 4th second. Okay. See, acceleration is given by dv by dt. So dv would be a dt, right? So this is going to be delta v. The integral is delta v, and this integral will be a dt from 0 to 4. So what is this? This is area under the acceleration versus time graph from t equal to 0 to t equal to 4. So this area would be how much? 1 by 2 into 4 into this height, 1 by 2 into base into height, right? So this would be 8. So that delta v. So change in velocity is 8. Initial velocity was 2. So 2 plus change 8 would be 10 meter per second. That's final velocity at the end of at 4th second. Get your point? This delta v is what? V final minus V initial, and V final is 8 plus V initial. So 8 plus this 2 is 10 meter per second. Okay, so this is how we can do these questions. All right.